Hello everyone, today we're going to recap exo and endothermic reactions. First of all, you're going to define an exo and endothermic reaction. Then you're going to give examples of exo and endothermic reactions in the science laboratory and also in real life. And then you're going to look at some data to decide if a reaction is exo or endothermic. Chemical reactions involve taking particles, rearranging them and making them to form bonds with each other. In order to rearrange the particles to make something new, you first need to break the bonds apart, then you need to form new bonds. When a reaction takes place, energy can either be released to its surroundings or taken into the reaction system. If energy is released to the surroundings will feel hotter and the temperature of the surroundings will rise. We have a name for this type of reaction. We call it an exothermic reaction. The definition of an exothermic reaction is one that transfers energy to the surroundings so the temperature of the surroundings will increase. We can remember this by thinking of the prefix exo in exothermic as referring to something exiting. In this case, heat energy leaving into the surroundings. There are three examples of exothermic reactions that you must remember. The first is combustion, such as burning a candle in oxygen. The second is neutralization, such as an acid and an alkali forming to make a neutral solution. And the third is oxidation, such as magnesium reacting in oxygen to form magnesium oxide powder. There are also two examples you must know of exothermic reactions used in everyday life. For instance, hand warmers or self-heating cans, which you might use if you were going camping. When a reaction takes place, energy can also be absorbed into the reaction from its surroundings. If energy is absorbed from the surroundings will feel colder and the temperature of the surroundings will decrease. We have a name for this type of reaction and it's called an endothermic reaction. So an endothermic reaction is one that takes in energy from the surroundings so that the temperature of the surroundings will decrease. We can remember this by the prefix endo at the start of the endothermic reaction, because it refers to something entering, in this case, heat energy from the surroundings, like entrance. Remember that in endothermic reactions, it is the particles themselves that absorb heat energy from their surroundings, and therefore the temperature of the surroundings around the reaction will decrease and feel colder. There are two examples of endothermic reactions that you must know. The first is thermal decomposition, such as copper carbonate being heated up to form copper oxide. The second is citric acid reacting with sodium hydrogen carbonate. Citric acid is a flavouring you sometimes get in sherbet, and sodium hydrogen carbonate is baking soda. An example that you need to know of an endothermic reaction which occurs in everyday life is sports injury packs. Let's check your understanding. Read the following question and then write down the answer 1, 2 or 3 on a piece of paper. Press pause while you're doing this. Let's see if you got it right. The answer is number 2. This is because exothermic reactions are ones where they release heat energy to the surroundings, so the test tube would feel hotter. It can't be number 1 because the test tube is described as getting colder. Question number 2. Read the question, pause the video and write down the answer 1, 2 or 3. Let's see if you got it right. In this case, the answer is number 1. This is because it's an endothermic reaction, and we know that in endothermic reaction, energy is absorbed from the surroundings, and that will make the surroundings feel colder. Question number 3. Again, pause the video and write down if you think it's reaction 1, 2 or 3 that shows an endothermic reaction. Let's see if you got it right. The answer is number 1, because this is the only one that shows a temperature change that decreases, and therefore if the temperature has decreased, we know that the reaction must be endothermic. Question 4. Choose which statement is correct. Pause the video and write down 1, 2 or 3. Let's see if you're correct. So the answer is number 3. An exothermic reaction will make the surroundings feel hotter because they transfer thermal energy to the surroundings. Number 5. Choose the correct statement. Write questions, answer 1, 2, or 3. Pause the video whilst you're doing this. Let's see if you got your answer right. The answer is number 2. Endothermic reactions make the surroundings feel colder because they absorb thermal energy from their surroundings. It cannot be answer number 3 because it says that endothermic reactions make the surroundings feel hotter, which is not true. We also need to be able to define activation energy, draw reaction profiles for exo and endothermic reactions, and explain the shape of reaction profiles. When particles react, they need to collide with enough energy, specifically kinetic energy. If there is not enough kinetic energy when the particles collide, there will be no reaction. If the particles collide with enough kinetic energy, they will react and form a new substance. The minimum amount of energy that particles need to react is called activation energy. Here we can see 2 pictures of different reaction profiles. One is exothermic and one is endothermic. During a chemical reaction, old bonds are broken and new bonds are formed. Drawing a reaction profile like you see below can help you tell whether a reaction is exothermic or endothermic. You will need to be able to draw and label these. The reaction profile on the left is exothermic. The reaction profile on the right-hand side is endothermic. At the GCSE level, you are expected to be able to represent exo and endothermic reactions as reaction profiles. You also need to be able to recognise whether a pre-drawn reaction profile is exo or endothermic. A reaction profile is similar to a graph in that it shows us a change in something over time. On the x-axis of the reaction profile, we show the progression of the reaction from start to finish. On the y-axis, we represent the amount of energy that the particles in the reaction have. A common misconception is that students think that the y-axis represents the energy of the surroundings, but this isn't correct. The y-axis represents the amount of energy particles have in the reaction. I'm going to show you what a labelled reaction profile would look like for an exothermic reaction. At the start of the reaction, we have the reactants. The particles in the reactants have a certain amount of energy, so we label this line reactants. In order to break the bonds between the particles in the reactants, they have to absorb heat energy from their surroundings. This means that the amount of energy the particles have increase, which is shown by the line going upwards from the reactants line. Eventually, the particles will have gained enough energy for the reaction to occur. We call this the activation energy. Once activation energy is reached at the top of the reaction profile, the curved bonds between the reactant particles have been broken, and new bonds start to form between those particles, making a product. At the end of the reaction, the products formed will have a certain amount of energy, so we label this line the products. In this example, the products have less energy than the reactants had, and this is because it's an exothermic reaction profile. At the peak of the curve, this shows us how much energy was needed to be gained by the reactants for the reaction to begin. The minimum amount of energy that the particles must have to react is called the activation energy, so we label this distance from the reactants to the peak the activation energy, or EA. The change in the energy between the reactants and products can also be labelled using a symbol called delta H, or overall energy change. If there is a decrease in the amount of energy the particles have, then the overall energy change is negative, and this means that the reaction overall is exothermic, as we see in our reaction profile below. We can see here that this reaction profile shows an exothermic reaction. For higher tier students and students in set A, B and C, we need to know why this happens. And we know that this is an exothermic reaction because more energy has been released when making or forming new bonds than has been absorbed by the reactants when breaking old bonds. We can do the same for an endothermic reaction. So here we're going to draw an endothermic reaction profile. In this case, the amount of energy that is released by the products when the products are formed is less than the amount of energy that is absorbed by the reactants when bonds are broken. The products, in this case, have more energy than the reactants. This time, you'll notice in the endothermic reaction profile that the products have more energy, so they're higher up on the y-axis, than the reactants. So the overall energy change in an endothermic reaction is positive. And this means that in an endothermic reaction, you will see that more energy needs to be taken in by the reactants to break the bonds than is needed to be released when new bonds are formed. Again, if you are a higher tier student, you need to know this, and you need to know that this is an endothermic reaction because more energy is absorbed from the surroundings breaking the bonds than is released into the surroundings forming new bonds. Again, you can see this by the red lines here, showing that there is a larger amount of energy needed to break the bonds between the reactants than the amount of energy needed to form new bonds. Let's check your understanding. What is activation energy? Pause the video and write down either 1, 2 or 3. Okay, let's check your answer. So the answer is number 3. Number 1 is correct but does not have enough information. It does not include the word react, and we need to include the word react for the definition of activation energy. Which of the diagrams show a reaction profile for an exothermic reaction? Write down 1 or 2. Pause the video now. Let's see if you got it right. The answer is number 1. The reason this is exothermic is because we can see the energy change would have been negative overall, and the reactants have more energy than the products. How do we know that this reaction profile is exothermic? Pause the video and write down the answer either 1, 2 or 3. Let's see if you got it right. The answer is number 2. Exothermic reactions have reaction profiles that show that the products have less energy than the reactants. Which diagram shows the reaction profile for an endothermic reaction? Pause the video and write down 1 or 2. Let's see if you got it right. In this case, an endothermic reaction profile is shown by number 2. This is because we can see there's a positive overall energy change and that the products have a higher energy than the reactants. How do we know that this reaction profile in the top right is endothermic? Pause the video and write down your answer 1, 2 or 3. Okay, the answer is number 1. We know this is endothermic because we can see that the reactants have less energy than the products, and so the overall energy change is positive. Number 6, why is this reaction profile incorrect? Pause the video and write down your answer 1, 2 or 3. Okay, let's see if you spotted the incorrect part of this diagram. So, the answer is number 1. The activation energy is not labelled correctly, and this is because the activation energy should start from the top of the reactants up to the peak of the reaction profile curve. And in this diagram, it starts from the products, which is a really common mistake to make. Let's look at an example question you might get on reaction profiles. What type of reaction does this reaction profile show? Explain your answer. Be careful not to be caught out here by the fact that the reactants and products are labelled with specific names. The reactants are methane and oxygen, and the products are methanol. A model answer for this would be that the reaction profile shows an exothermic reaction. This is because the reactants have more energy than the products. Now you're going to complete an independent task. For each of the following, 1, 2 or 3, you're going to explain which type of reaction does each reaction profile show, and explain your answer using the model in the box below. Pause the video now and restart it when you've written all of your answers and you need to check them for each of the questions. Okay, let's see if you got it right. Check your answers now. The gaps are filled in red from the model. If you didn't get your answers right, go back and rewatch the explanation again of my model answer. Okay. If you're a foundation student or you're in set D or E, you can stop watching now, as the next content only needs to be remembered by higher tier students. If you're a higher tier student or you're in set A, B or C, then continue watching. As a higher tier student, you also need to be able to explain why reactions are exothermic and endothermic in further detail. The process of energy being taken in to break the bonds itself is an endothermic process, as heat energy is absorbed from the surroundings. When new bonds are formed, heat energy is released into the surroundings, so bond making is an exothermic process. We can remember this by using the acronym BENDOMEXO, where breaking bonds is endo and making bonds is exo. The reaction profile on the left-hand side shows an exothermic reaction. This shows an exothermic reaction because more energy has been released when forming new bonds than has been taken in when breaking old bonds. Therefore, the reactants have more energy than the products. This can be seen as the larger red arrow shows that more energy is released when forming bonds, compared to the smaller red arrow which shows less energy absorbed when breaking bonds. The reaction profile on the right shows an endothermic reaction. This is because more energy has been absorbed when breaking bonds than has been released when forming new bonds. The products have more energy than the reactants. This can be seen as the larger red arrow shows that more energy is absorbed when breaking bonds compared to the smaller red arrow, which shows that less energy is released when forming new bonds. Let's look at an example question. What type of reaction does this reaction profile show? Explain your answer. We've already done a similar question to this, but now we have to explain it in more detail. The reaction profile shows an exothermic reaction. This is because more energy has been released forming new bonds than has been taken in breaking old bonds, and the reactants therefore have more energy than the products. Using this model, we're now going to complete some independent tasks on paper. For each of the following reaction profiles, 1, 2 and 3, you're going to answer the question, what type of reaction does each reaction profile show? And you're going to explain your answer using the model answer in the box below. Pause the video now and write down your answer for 1, 2 and 3, and then unpause again when you're ready to check your answer. Okay, let's see if you got it right. Check your answers now, the gaps are filled in red. If you did not get your answer right, go back and rewatch the explanation of why reactions are exo and endothermic. Good luck with your further practice questions and thanks for listening.